Hello. Good morning, everyone. How are you feeling? It's a bit early for a seminar, isn't it? So welcome to the PT-1210 Turn Your Amiga into a Pro Tracker DJ Player seminar. My name's Ian, or Hoffman. Oh, hang on. Have I missed one? There we go. Welcome. So my name is Hoffman. I'm a DJ, coder in the PT-1210 team. I also helped come up with parts of the concept, and I'm also a user of it. Another member of our team is Akira. He also is a DJ, helped with the concept of this software, designed the UI, does documentation, website, and is also another user. And we also have Dopefish, our new coder that's joined the team last year. He's also a wannabe DJ. So, what is PT-1210? So it turns your Amiga into a DJ-friendly module player. So what that means is that you have the kind of functions you would normally have with either a CDJ or any other kind of modern DJ equipment. So you can adjust the tempo and pitch of a song. You can nudge it left and right to push them in and out of time, preferably in time. We have looping functions in there, so you can loop patterns and sections of patterns. Channel muting, and also a DJ-style UI, which we'll see in a moment, and also Pro Tracker-style visualization, because everyone loves that kind of thing, right? So this is a typical setup that you'd have. This one obviously having two Amiga 1200s. So you'd obviously route your audio from each Amiga into each separate channel of your DJ mixer, which is then obviously routed up to your speaker system. And then you route video out to a couple of screens so you can actually see what you're doing, and obviously a set of headphones so you can hear what you're doing. This is one of my setups at home, thanks to my blurry photography there. Running two 1200s and my Allen and Heath mixer, which is very old and battered, but still works. And these tiny little LCD screens that take a composite video input that fit really nicely on these devices. Which is really good for seeing what you're doing. So, where did it all begin? So this post in March 2012 from Akira on the English Amiga board forum, asking about how the possibility of playing a module, or at least pitching up the samples within a module. So the first problem you have, so let's say, for example, you take a Pro Tracker module and you change the BPM within that module. Obviously, any drum loops that you have then go completely out of time. So what we do, so obviously this was the first question, and as soon as I saw that, I knew exactly what he was after. And obviously, if I get some time before Easter, I'll give this a go. So this was the crowning moment. So I asked, obviously, how we could possibly do the pitch calculation. And Robinson B5 kindly gave me, because I was a bit of a rubbish coder back in 2012. I'm a bit better now, thankfully. So he just gave us these two lines of code, which essentially are the crux of how this whole thing works. So it basically does the calculation. So it takes the period that or the sampling rate that the sample's playing at, and using the BPM that your tune is supposed to be in and the BPM that you're playing the tune in, recalculates the pitch to then shift everything up or down to keep everything in time. And there it is. I just cut the code, and it works a bloody treat. Okay, so these are the first couple of prototypes. You can see, obviously, on the left here, we've just got our oscilloscopes and a few displays. But obviously, the first time we had this up and running and got the code in, it worked, and we were pretty impressed with just how stable it was already. There was obviously a few things to iron out. A later version, obviously, we added the pattern display. And then we fast forward to version 1, which we released in revision 2014. It was coded 100% in assembly. It was not system friendly, has no folder support, and didn't work on every Amiga, and was built using DevPack on an emulator, which seriously sucks. It was really bad. But it worked, and we released it, and it was fully functional, and we were very happy with that. So then we get to 2014 to 2018, which was our quiet years of development, mainly because I was off doing these demo party things, but also the daunting aspect of having one huge assembly file and then trying to add lots of functionality to that when it's all in assembly and all crushing the system is pretty off-putting. So, Dopefish to the rescue, who joined the team in 2018 to get this thing up and running.
So, hi. Just a bit about me. I'm someone that grew up using Amigas. I love the demo scene. I love everything to do with the Amiga. I particularly like trackers and tracker music. And I might have released a couple of rubbish chiptunes in the past. But I met Hoffman at, I think, my second demo party ever, which was Sundown 2010. I think that was the year you released J-Step, and it just blew everyone away, and the rest is history. And I sort of became a programmer around 2012, and I worked on this thing called Milky Tracker, which some of you might have used. And then last year I joined the PT-1210 team, and I just saw this opportunity where I might be able to help Hoffman out, and I thought I'd get involved. So to start with, I just took a look at what the state of the code was in, and sort of thought about how we could do it better. And as Ian said, DevPack, it's all right, it gets the job done, but I think we can probably do better these days. So we switched over to Visual Studio Code as an editor, which is quite nice. There's this awesome Amiga assembler extension. I think it's by a guy called Paul Reingard. I don't know if I've pronounced that right, so sorry, Paul, if you watch. But it lets you hover over things like the register addresses for the Amiga, and it shows all the documentation right there under the cursor, so it's quite handy. It means you can put the hardware reference manual away for a while. It highlights and indents all the assembly code quite nicely. And it also, the editor itself has a line-by-line debugger, so as long as the tool chain you're using can integrate with it, then you can use debugging tools from within Visual Studio Code, which is quite nice. As an assembler itself, we switched to VASM or VASM, which is part of the VBCC toolchain, and that just went straight through the DevPack code, no problem. I don't think we even needed to change anything to make it work. So that meant we could assemble a code from a PC or from a Linux machine. WinUAE is before FSUAE for me, because I'm on Linux most of the time. The newer versions of these emulators have new debugging features in. Some of them are quite unstable at the moment, but it's getting to a point where we can almost do line by line from an editor like this in the emulator and watch the emulator, get stuck on breakpoints and stuff. So we're almost at the point where we can just have these two things side by side and debug the code right there with the emulator in front of you. And then we want to bring in a C compiler so we could rewrite some of the non-critical stuff in C. And we're currently using a make file to just build everything. There's two modern Amiga C compilers that are quite relevant these days. One of them is VBCC, which has been established for quite a long time. It's had 68K support, I think, from the very start. It's pretty lightweight. You can just unzip a couple of things and you've got the whole thing set up. You can compile on the Amiga itself if you want. And it supports some Amiga things like marking certain variables as chip RAM or fast RAM, or writing safe interrupt handlers. It does have a couple of drawbacks though, like some of the code it generates is not quite as optimal as it could be. It doesn't support C++, not that it affects us because we're just doing pure C. And it was last sort of updated in 2017, so it's not that bad, but it just has a slower release cycle than the other alternative. So this is something that's, GCC 6 is something that's just appeared within the last couple of years. A guy called Bebo has ported this to create 68K Amiga code, which is amazing. It just blows my mind that something that was sort of the state-of-the-art C compiler for modern desktops is now generating code for this 80s machine, which is fantastic. And because it's GCC, it has like 25 years of, compiler experience in there. So the code it generates is pretty decent. The guy doing the port is very actively seeing to tickets and stuff on GitHub. He's very quickly making updates to it. So it's under active development. The downsides are you have to compile from a PC. There's no hope of running this on an Amiga at the moment. It's just huge. So you are cross-compiling with it. And some of the things are not quite stable yet. So like between versions of GCC, I've had PT-1210 just crash for no reason. So you just have to pick a good version and then stick with it and hope for the best at the moment. So it's got pros and cons. So the point is we're trying to compile with both, and we're just trying to make sure that the code is good between the two, and just keeping an eye on what the code is like after it's been compiled. So to start off with, we took this huge assembly file that was all of PT-1210 and split it down. And thankfully, it looked like a horrendous task, but you'd actually written the functions quite nicely. So it was prefixed with FS for file selector functions and things like that. Just made it a lot easier. So we split it down, and that way we could just replace one component of PT-1210 at a time with C code. So we would literally just choose a function, rewrite it in C, swap the assembler out, and then compile and test and just make sure nothing broke, which happened quite often, but such is life. So how do we start doing this? If you want to mix assembler and C code, all you've got to do is just export and import the labels. So in assembler, everything is just a label. And so if you write an xdef directive, you can just make that label available to other components. So things that are in assembler that we want to reach from C, we just put an xdef next to, and things in the C code, we just put an xref next to that we want to import. So that sort of bit of code at the bottom right is kind of like the hello world where we first started to get C code interacting with PT-1210. And all that does is just opens the Amiga DOS library and then calls PT-1210 as a function. And then it cleans up after itself. And gradually we're just bringing stuff out into the C code one piece at a time. Where it gets a bit dodgy is where you need to make sure that the parameters that you're passing between the C and assembler code, some stuff is expected to be in registers, some stuff is expected to be on the stack, so it can get a bit tricky to make sure that's all right, and we had quite a lot of crashes because of things like that, but you kind of work it out. So this is an example of an assembler function that we rewrote in C. So this is the function that generates the file browser list, so when you start PT-1210, it looks in the current directory, it scans over all the modules, and if it's a valid module, it adds it to the list. And that turned into something like this. So it's a little bit shorter, it's a bit easier to understand. You can see there's a loop. It's easier to call the operating system functions like examine and lock from C. You don't have to set it all up into the registers. You can just say the function, it's just so much more readable. This is another example. This is the 4 functions that mute and unmute the channels when you press 1 to 4 on the keyboard. The C version looks like this. So it's just so much shorter. Yay. So the goal is to try and make PT-1210 as system-friendly as possible, so that it can coexist with the OS. We don't want to boot it out anymore. So we removed all the hardware banging where we could. And so the interrupt handlers, we kind of register them with the OS framework. We no longer just read the keyboard registers, we actually receive events from the input device. So this means that if you have one of these crazy souped up Amigas with a USB add-on and then a USB keyboard and stuff like that, it would probably just work because it's just using the software device. CIA, same thing, we just use the system functions for that now. We had some problems recently with tempo drift, which we could probably go into detail later on or something. But we fixed that recently and it's all working pretty well. We don't just assume we have the audio channel, so if you decide to start Hippo Player or something for some reason and then start PT-1210, it won't just try and use it. And we're trying to make the graphics a bit more system friendly as well. We're still kind of using the copper and the blitter and everything directly, but we do open an intuition screen so we don't just draw over the workbench, which in theory should mean that we can flip backwards and forwards between them once we add the missing code. So it's almost there. And because we're doing all this, some of the weird bugs that were in the first version have just disappeared. So one example was that you just could not load any songs from floppy disk under Kickstart 1.3. 2 and 3 were fine. Don't know why that is, but it was just because we'd taken over all the interrupts and disabled the OS, and now that we don't do that, it works. And because we're running inside the OS properly now, we can use things like Enforcer to trap like bad memory accesses, and it's much easier to debug. Just a couple of like hints that we picked up while working on this. So the serial port is very useful for getting info out of the program while you're trying to figure out what's going on. And there's a nice function called kprintf. You can write print strings over the serial ports, even within inside an interrupt. Which it took a while for me to figure this out. I was trying to do like a normal Amiga DOS print statement inside an interrupt, and the whole machine was hanging, and it's obvious to me now why that was, but it wasn't at the time, and then I realized that this function existed, so that's pretty useful. You can use stuff like Enforcer and Seg Tracker, as I mentioned. You need an MMU CPU for this, but this will let you trap bad memory accesses and null pointers, and it can help get an idea of what's going wrong if things are crashing randomly. And version strings, we did this just to make it easier for testers and ourselves, really. So we're kind of debugging things, working on new features, and passing executables around. It's a lot easier to get back to which Git commit we were if the version number was baked into the exe. So Amiga OS has this feature where it will let you read the version of any library or component with a version command. So as long as you've got a magic string in the binary, which we now add, you can get back to where you were. So this version number is like 1.0, 70 commits after the last stable tag, and that's the Git commits, as you can see in the log. So it's quite a handy feature. And do you want to talk about this bit?
Yeah. So I don't know if any of you have used the software yet. Obviously, the thing that we'd love for you to do is come and have a play with this when we're done with the seminar and have a mix. So obviously we're kind of, we're getting a lot of things fixed, bugs removed, making it more stable. But we're going to improve the file browser, so you'll actually have a file browser. So at the moment with PT-1210, when you fire it up, it scans the current folder and you can't move from that folder. So obviously if you've got your drum and bass folder and your house music folder, you have to quit the software, change your directory and go back in, which is pretty lame. So we are very close to getting this ready. We're also thinking about adding track metadata, so you can change you can log artist names, BPM, configuration, cue points, that kind of thing. Directory caching, so on some of the slower Amigas like the 600, reading the folders and sorting that information can take quite a bit of time because the process is a little bit underpowered compared to, say, the 1200. So we've worked out a way that's going to be super quick once it's scanned it, so you can just keep loading those up really quickly. We've got a principle that we've developed that, so on some Pro Tracker tunes, you'll see that they'll have a BPM that's not correct because they're using like a frame speed of like 4 or 5. So we've worked out a way of storing a little bit of information inside that Pro Tracker module, then adjust the BPM display and in the file browser so you know what it's actually running at. And obviously the big one that everyone wants is configurable controls, which obviously the layout that we've got for controls at the moment is static, but we're obviously working towards having that completely configurable, maybe even, I think we've got the CD32 pad support, which we're kind of working on at the moment as well, so you can actually control this with the CD32 pad, which is pretty cool. And that's pretty much it for our seminar. This is where you can find us. We're on Discord. You can obviously find our website, which is you can download the folder. We've got the software. We've got a few module packs up there as well. You can join us on Discord. We are on Facebook, but we don't use it that often because Facebook's lame. And you can catch us on Twitter as well. And now you can ask us anything. So, any questions? Don't you dare, Scott.
Does this work with tunes which apply some speed jumping tricks?
What, like pattern tricks? Sorry, the question is obviously, does it work with anything that does like speed or pattern tricks? So in terms of the replay underneath, it's a standard Pro Tracker. I think it's a 1.2 version of the replay source, which hasn't changed and supports all of the bugs that are in Pro Tracker. So the base, that is exactly what we're using. So yeah, I mean, I've put some of my more crazy stuff through it, and it plays them just fine. Yes, Scott.
I don't think I saw any fractional BPMs there. Am I just missing something, or is it?
No, you just go back.
Might just be fine.
Yep. There. So yeah, fractional BPMs was the question. Yes, we can do that. You can hold down shift. So if you've got something that's slightly odd speed, you can obviously nudge it into, to be pretty darn tight. I mean, we've just recently fixed the CIA interrupt on this. So now previously a 1200 and a 600, when they're running at the same BPM on the display, was not running at the same BPM on the two machines. But we've since fixed that, so they're now pretty darn rock solid. I think we get about a drift after about 3 minutes now, which is pretty darn good. But obviously you've got controls to push that back into place anyway. Any more questions? Yeah.
Have you thought about supporting AHS?
Have we ever thought about supporting any other formats? No. But the full answer is yes, we've thought about it. But AHX is a complex one because the replay code is absolutely horrific. If you've ever seen how fast it runs on an A600, having our UI on top would probably crush it to pieces. So we might at some point maybe investigate the possibility of adding 4-channel Octamed support, because there are quite a few tunes in Octamed that are pretty darn good. So we might do that, because obviously it kind of fits quite well with how we work with this anyway. But I think that's, in terms of adding additional formats, it's a very complicated thing to do, because this whole thing was built just from that replay source, and then we built on top of that. So everything is very much intrinsically linked to that replay code. So if we replace that, then everything breaks. So, yep.
It might be more a question about Amiga, which I don't remember. But what to start with the chip RAM? Like, how often would you have to restart one of the computers because you're running low on chip RAM?
At the moment, it's pretty good because we don't do much in the way of dynamic memory allocation. Essentially, we allocate the RAM we need to load the module, and then when you load another one, it removes that and then reloads it. That might change when we do things like dynamic folder listing and things like that. So we've got we can set a maximum of the number of files you can list in a folder at the moment to like 50. But we want to make that dynamic, but obviously that means that we're then kind of allocating small chunks and deallocating small chunks. I guess in terms of fragmentation, we'll have to see how that goes. But it's not really a problem when you're just playing tune after tune.
Just one question sorry, it's a dumb question. Are those Amigas linked in any way?
Only by the sound into the DJ mixer. So there's no... So you do still need to actually beat match. But in terms of the BPM display, most of the time you could just set that up to be the same BPM, and they are pretty rock solid. And any more questions? Fabulous. All right, well, thanks very much, everyone. If you want to come and have a play with the software, we're going to probably get the speakers ramped up a little bit, and we'll play some tunes. Who's up for that? Yes. Thank you.
Thank you.